Good morning, everybody. So with a little tiny bit of delay, we are going to get along with the morning session. This next session is called the Natural Hazards Engineering Research Infrastructure session. And could I please have the slides? Yes. So for this session, we had invited Dr. Franz Cordova, director of NSF. She could not come, but I want to read some of the comments she sent. She says, I'm also pleased that you are including a session on the importance of natural hazards engineering research infrastructure facilities supported by the National Science Foundation. As you know, this type of research is critical to our national security, and I'm honored that the committee chose to highlight this important topic at your event. So what are NHERIs? There are 7 facilities, and there is one disaster rapid response center, a coordinating center, and a computational modeling center. And all of these are experimental facilities and support facilities to deal with our nation's problems with hazards of different kinds, mostly of the natural hurricanes, earthquakes, things like that. And these in particular have to do with mostly with regards to hurricanes, et cetera. So yesterday, many of you went to see the Wall of Wind. And the Wall of Wind is one of the NHERI facilities. And its goal really is to enable research and education to look at resiliency and sustainability of new and existing buildings, cladding systems, lifeline infrastructure to prevent wind hazards from becoming community disasters. So what I'm going to do is I will tell you a few slides about NHERI. Those of you who saw yesterday the Wall of Wind, it will be a repeat. And then I'm going to introduce to you 2 panelists who also have NHERI facilities at their universities, and they will tell a little bit about their facilities, and then we will open it up to others to ask questions of how they can participate and how the 2 of them have handled having these facilities at their universities. So the NHERI, as you saw, has got the large 12 fans that can create hurricane level 5 winds. There is a staging area, there is a control room, there is a whole flow management system, there is, and you can put large scale models to test I would say in situ over there and actually do the testing on them. And you have a large staging area so that people can bring in their experimental setups from everywhere else. So the unique capabilities that this facility offers is handling up to category 5 hurricane winds, simulating that, multi-scale testing of full, large, and small scale, and specifically being able to do destructive testing and then be able to assess when failures occur for bridges and infrastructures. They can create wind-driven rain, and they can and look at various structures, bridges, renewable energy systems, lifeline infrastructures. And yesterday you saw also, for example, traffic lights from FPL. You saw a video about that. This facility gives user support, and so the whole idea is that people who have these experimental facilities, NSF wants others where the faculty are funded to come use them. So in the case of Wall of Wind, there is assistance provided to faculty from other universities in preparing their NSF proposals, designing the experiments, what budget is needed, et cetera. There are also travel funds available for the Wall of Wind and users workshop. And there is also, if a faculty member currently has an NSF grant and does not have funding written into it, then the Wall of Wind will offer basically free access to being able to do the numerical studies and safety simulations and validating those with the experimental data that they have. There are the 2 contacts. Dr. Arindam Chowdhury is the director, and Dr. Yonis Zisis is one of the key faculty members in there. Of particular note is a workshop that is going to occur June 15th and 16th. So if you are interested or your faculty are interested, please have them register for it. And for this, up to $600 will be given per participant for reimbursement. At this point, I'm going to introduce to you Dr. Sharon Wood. Sharon is the Dean of the Cockrell School of Engineering and holds the Cockrell Family Chair in Engineering at the University of Texas at Austin. She has been a member of the faculty there for more than 20 years. Prior to her appointment as dean, Wood served as chair of the Department of Civil, Architectural, and Environmental Engineering and director of the Ferguson Structural Engineering Lab. So you can clearly see that she is in the field of what these NHERI facilities are, unlike somebody like me who's a biomedical engineer. And so you all will be of different backgrounds, and you may end up having a facility like this that you have to figure out how it is going to be managed, et cetera. Wood's research interests focus on the design and behavior of concrete structures, and earlier in her career, she studied earthquake response of buildings, while more recent work is related to evaluation of reinforced and pre-stressed concrete bridges and development of passive sensors to detect the onset of corrosion in concrete structures. Dr. Wood.
Thank you. Thank you very much. So,
can we get some help in the next slide?
Thank you. So I'd like to talk to you today about the NHERI facility that's at the University of Texas at Austin. This is a series of large-scale mobile shakers that are used to look at the response of soils, natural soil deposits, and possibly some soil structure interaction. Our facility is a little different than any of the other facilities because these vehicles go out in the field. And so the researchers from your university would just come up with a field site that they specifically want to test at, and our team would go and meet you there. And so the work is all done in the field. So this was part of the NHERI program over the 10-year part of NHERI. They went to 50 different field sites around the US, including Hawaii, and they also did quite a bit of work in New Zealand. I'll talk to you about that in a second. But you notice their motto there is, "The nation is our laboratory, have mobile shakers will travel." So they're clearly, they want to go out and work with faculty at other universities. So in Christchurch, over the last 5 to 6 years, they've had a number of very damaging earthquakes. Their central, about 80% of their central building district, or central business district, was destroyed by these earthquakes. And so the team spent the better part of a year with the largest of their mobile shakers in New Zealand doing a whole series of tests. What happens is, because it's a very complex geological formation, all the work that had been done before was only getting down to like the first 40 to 80 meters of the soil. Well, it turns out that bedrock is down at over 1 kilometer of depth. And so with the series of tests that they have done, they have been able to do that entire profiling. So that will allow engineers, as they're rebuilding in this area, to have a much better understanding of what the risks are. In addition to the mobile shakers, they have a whole series of equipment, including, you see here, geophones and seismometers. In addition, there's another NSF-sponsored program where if you need other equipment, you can get it from them. So or other types of sensors. Another thing that they've done is they've tried to look at what happens to the nonlinear response of soils in site. And this is particularly important when there's some kind of cementing in the soil, because when you take a sample to test it in the lab, you lose that cementing action. So this happens to be something at Yucca Mountain in Nevada. As you know, that's where there was plans to have the National Hazardous Waste Repository. And what they found was that there was a 3-fold increase in the large strain stiffnesses compared with what they had done in laboratory testing. Liquefaction is something that's also very important. And again, the strain rate at which you apply the load can have a huge impact on when you estimate liquefaction will occur. So this is just showing some results from back in Christchurch. And then this last one, I think it shows you kind of the excitement that they have around taking their trucks to various sites, is that you have these geological formations that seem to be unstable. That they're showing here a hoodoo that's about 20 feet tall. The USGS has used this to try to estimate the magnitude of previous earthquakes. Well, now they can put a low level of shaking, they can have instruments at various locations, and they can actually get a feel for how these geologic formations actually respond. So much like what you heard at Florida International University, we also have a series of workshops, and all that information is also available online. And I will pass it over to introduction of Stephen from Lehigh. But,
Yes.
yeah.
So Dr. DeWeerth is the Dean of the P.C. Rosen College of Engineering and Applied Sciences and a professor in the Department of Electrical and Computer Engineering at Lehigh. Prior to his arrival at Lehigh as Dean in September 2016, and note that he's a biomedical engineer in electrical and computer engineering, he was a professor in the Wallace Coulter Department of Biomedical Engineering at Georgia Tech and Emory University, a professor in Georgia Tech School of Electrical and Computer Engineering, and the Associate Dean for Research and Innovation for its College of Engineering. So Dr. DeWeerth also has had the experience of founding the chair of the Department of Biomedical Engineering at Khalifa University in Abu Dhabi, and he implemented a major redesign of the BS curriculum for the entire College of Engineering. When I called him, he said, NHERI? And so I said, yes, NHERI. And so, Dr. DeWeerth.
Yes, it was good. It was thanks to Ranu, I know we have one of these facilities at Lehigh. So she said, I've been there since September, so it's been a great opportunity to learn a little more about what we have. So our facility is the large-scale, real-time, multi-directional hybrid simulation experimental facility. And after seeing the wall of wind yesterday, I think we need to get our marketing people together with our civil engineers and come up with a catchier title. So, but what they're doing there is very cool. So I want to tell you a little bit about it today. So our NHERI, first of all, we've had a long relationship with NSF in civil and structural engineering. We had one of the first NSF ERCs, and it was titled Advanced Technology for Large Structural Systems, ATLAS, that's been around for a long time. So that laid the foundation, literally, for a lot of what we're doing here, and the facility that actually the NHERI project is in. We were also part of the NICE network from 2004 to 2014, one of the 14 schools that was there. And so we've got a long history since the early 2000s of working with people around the facility that is now our NHERI facility. So the major focus of the facility is to look at reduction of losses from natural hazards, particularly at looking at building and related resiliencies. So the focus of our NHERI site is hybrid simulation. So a combination of physical simulation through a large-scale structural facility as well as computational simulation. So the facility itself, the ATLAS facility, this is about probably a quarter of the building, but the wall there, the reaction wall is about 6 stories tall, and the long wall there is about 100 feet long. So it's a very large reaction wall and floor that we can attach structures and devices to. And that forms the basis in which the NHERI facility is working. So the NHERI facility has a number of components. I'll talk about each of them briefly here. So first of all, there's a set of actuators. There's 5 large actuators. Each one's about 2 meganewtons of force and has about 1 meter per second velocity. It can go up to 1 meter per second in velocity. So they're very, very large, fast actuators. And the key about these actuators is they can basically be put anywhere in that structure, the wall and floor that you saw a moment ago. So we can build structures and apply displacements and forces to those structures using these actuators. There's also, in order to measure what's going on, we have a lot of advanced instrumentation, including optical imaging, as well as a lot of sensors that measure, you see there from a millimeter to 100 meter size objects and their motions. And what you see there is actually a heat diagram of sorts that's overlaid on one of the sensor walls to show the actual displacements that are occurring on the wall. Then the computational facilities, as I said, it's a combination of the physical models as well as the computational models. And so we have large-scale computational facility that backs up the part of that. And this is the types of things we do there. And you'll see there's a structure, a steel structure in this case. I've learned in Bethlehem, Pennsylvania, steel's an important thing still to this day. So we do a lot of steel structures. But you'll see the actuators that I talked about mounted on the right wall there. So we're able to build large structures and move them accordingly. So I think the easiest way just to tell you a little bit more about the facility is to talk about a specific project. So this is a project that we're doing that faculty members from Lehigh are doing with faculty members from Cal State Pomona, Cal State Northridge, and I guess both of those from Northridge. So with a couple of the Cal State schools. And the idea here is to look at the effects of dampers on reducing the movement of buildings during earthquakes. So they're applying lateral motions computationally and physically applying lateral earthquake motions and looking at what happens to the structure with and without dampers. So they have both an analytical substructure in the computers as well as an experimental substructure, which is the one you saw a moment ago. Those are connected through a simulation coordinator that basically applies displacements and measures forces from both the physical system as well as the computational model. And then the input to the system, as you see at the top there, is real-time ground acceleration. Well, we don't move the ground actually, but we put it in a reference frame so that the ground is still, but the building is moving as if the ground were moving. So, and then we see the real-time structural response out of all of this. So this will be a movie in a moment, but I'll just show you what's here. So you see on the top left there's the analytical substructure. Over on the right, you see a couple of the dampers that are actually moving during this the simulation. And in the middle there, you can see 3 sets of dampers. And then down at the bottom, there's a couple of. Oops! So I did the wrong thing, as they told me. Could you start the video, please? So you'll see over at the right, the damper's actually moving, and you'll see the whole structure. If you look carefully, the whole structure is moving. I've been told if the dampers weren't there, the structure this would be destructive testing, that it would actually break the structure, that's how much better the dampers do than if we didn't have them. The reason we need the hybrid simulation here is because we can't build the scale of structure that we would like. So in the computational simulation is actually looking at larger structure, but the dampers have such complex nonlinear properties that they are hard to model computationally. So we're using the physical dampers and the structure around them, and then a computational model that expands beyond that. This is just an example of another one of the projects that we're doing with UT Tyler and Notre Dame, and this one is actually focused on the computational model. Actually has a much larger structure than what we can fit into our large facility. And again, you see down there, they're studying the actual displacements of the wall in that heat map in the bottom corner there. So we have a number of ways that we do outreach from our facility. As you've heard, these facilities are meant to be user facilities. So we have researcher workshops. We do K through 12 outreach. I have to say, the Atlas facility, when I first walked into it, I was quite impressed. It makes quite an impact on people who come in, including hopefully future budding engineers. We have seminars, experimental facility tours. So if you're ever in the area, please come by, and please, encourage your investigators to look at this as an opportunity for them to do their research. And this is the team. The 2 leaders of this are Jim Rickles at the top left there, who's the NHERI director, and then Richard Souse, who is the Atlas director. Thank you very much.
Are there deans in the audience who have NHERI facilities? If you have, raise your hands, please. Scott Ashford, Oregon State University. So this is an opportunity for you all to ask questions, but I will start with Sharon and say, could you tell us a little bit, since you have had a lot of experience with these, of how have you gone about engaging with the rest of the community to help them come?
Yeah, I think this was really an experiment by NSF, because for science, they have had shared use facilities for a long time, but every university wanted to have their own experimental facilities, and they would try to support them on their own, and with funding models changing, this became very difficult. So Scott and I were involved when NEES was first starting as to how would we develop the community to actually share the facilities. And I think the things that have come out of it are, how do you really make the facility so that users can come in from somewhere else? they know how to schedule it, they know how to set the budget, and they can actually take, full advantage of this facility. And that's probably been the biggest cultural change. I think the other thing that has come out of this was really sharing data. And although I didn't get to talk about it, the simulation and data that come out of all these experiments are actually at the University of Texas. And so researchers are looking at things differently now. They're designing their experiments and they're archiving their experiments such that the data can be shared and other people can use it. And then finally, the third thing is probably we advertise payload projects. So if there's something going on at Lehigh and I'm at another university, I realize, hey, I'd really like to be able to study the dampers, I can actually get involved with a project that's ongoing. And I think all of this is what NSF has facilitated to try to make better use of these national facilities.
Thank you. So Steve, as a new dean and as somebody who is themselves not in the field of civil engineering, can you share with others the experience of getting, this is a major facility, and it's a major investment, and so how have you gone about getting engaged with that community within your own university, and also how are you being able to help support your group to get the word out, this being one of the opportunities?
Yeah, well, I think that, as I said, this NHERI facility is large, but it's in the whole infrastructure of our Atlas facility. So it's a huge user facility, and I think, like any large user facility, we struggle to figure out the right financial models. We try to get industry in doing things. So we have a very Atlas also has a very large, one of the largest testing machines in the country. So we break lots of big, everything from bumpers that are going into ports to large pieces of concrete from bridges. And so I think there's a big logistical challenge with these large facilities of getting things in and out and just finding the right funding model. And so I think, this is an ongoing, certainly as a new dean, you can imagine I've come in and realized what the financial realities are of this and trying to figure out how to best utilize it for the sake of the university. But I'll have to say, I'm thrilled to have a facility like this, and to have, these large-scale facilities are hard to come by, and to be able to have one of these and really make it a highlight of our college, I think is something that we appreciate being able to tell the world about. So I was happy to be able to come here today and do that. So
we'll take questions from the audience. Do you have any questions about these facilities or in general about the NHERI program?
One of the questions I have specific to the Lehigh facility is those are large-scale experiments. It's not a mobile system, for example. How do you work through the details of an experiment that's going to how do you work through the details of an experiment that's going to take weeks or months to set up and run, given the scale of the types of things that happen? And just if you could sort of share some of that.
I was hoping I didn't have to pull the "I've been there for 6 months" card on the very first question. But
Do you want me to answer?
Would you answer that for me?
So one of the things that NSF has done is they provide support for staff who specifically will help in that respect. So they get involved at the design stage, make sure that the researchers from other schools know what all the steps are. And I think the hardest part, though, is a lot of times when you're doing a big experiment like that, you think, wow, now that we've learned this, it'd be really nice to do something else and something else. Because there's a tight schedule, you don't have that opportunity. But at least for the pre-planning and all the scheduling, staff is there to help the researchers from other schools.
And I'll say this, it's the same thing at FIU, and that is partly attending those workshops then gives you an assessment of what is it that you need to do, and engaging with the host site, and they will help you prepare proposals that will help you get your budget together and get your timing together so that when you apply for a proposal, you will know that. And one of the things that at least Arindam pointed out to me again and again is that when you do such a big experiment, it's a one-shot deal. So you really need to have everything worked out. You can't say oops and then try again. So it really has to be worked out really well. And so there's a very strong partnership between whatever is the host facility and the faculty that are bringing in their projects.
Maybe you have already mentioned it, but can you give us an example of how the funding model works? Who is funding your facility? Is it the university who is funding it, NSF? That's one. The second one, do you have some numbers of how many outreach activities you do, how many researchers approach you and say, I want to collaborate with you to do some experiments and submit proposals?
Yeah, so in the current funding model, there, just like a service center, there are NSF-funded rates and rates for people who are not NSF-funded. And so when it's an NSF-funded project, they will pay for the staff to be out in the field or to be working in the labs with the external researchers. So to be honest, I do not know what the demand has been. I think a lot of that depends on how much funding NSF is putting into the programs, and we know that's in flux right now. Ours was fairly heavily used during the NEES program, but I don't have data right now for what's happening.
So I can tell you something about the wall of wind, that before getting the NSF designation, a large segment of the users was industry, and as you saw, FPL talked about it. But now being an NSF designated facility, it is actually a requirement that you have a certain proportion, and I don't remember the exact number, that it has to be NSF funded faculty. So there is really NSF wants these facilities to be used because as you know, they have invested in it quite a bit, and so I think that at least at the Wall of Wind, we are looking to reshape the balance of that portfolio so that more of the community is able to utilize the facility.
And given that ours is embedded in a facility with a larger scope than just the NHERI project, I think that to the previous question, the logistics are even more challenging around scheduling and the like, and I think our team does really well with that. But the funding's also very broad. We do get a lot of industry requests, oftentimes, you know, to the logistics on fairly short notice. If something, you know, if a bridge part breaks somewhere, they want to bring it in and test it quickly while they're repairing the bridge or whatever. And so this is so I think we have that going both with the logistics and the funding. But we have a lot of, you know, obviously a lot of federal research funding that comes to this. The state of Pennsylvania, because it ties in with infrastructure, state of Pennsylvania has a fair amount of money that comes into the facility. And you know, everything from individual or small group projects up to very large kind of NHERI related projects. So,
in the keeping us back on schedule, we took a little longer break. So at this point, for any more questions, please feel free to reach out to us later, and we will be able to give you contacts of the NHERI directors so that you can encourage your faculty to join that. Thank you, Sharon. Thank you, Steve.
Thank you.
thank you.